Welcome to episode 16 of the PM Blend. I'm Mark Powell, co-host here, 2 seats over, Joe Finksler.
Hi.
Joe?
How you doing today?
I couldn't be any better.
Well,
How are you?
good. I'm great.
Can you believe we've made it to Sweet 16?
Well, you know, at some point, Ann's going to pull the plug on us, I know, but
Yeah. I'm surprised it hasn't happened yet, but we'll see how this one goes. The plug might get pulled mid-show.
hopefully these guys know something.
Yeah, we do have some stars today, so they'll carry us. And that's
Okay.
usually how it goes. We get carried by our guests. So, but to my right here, Andy Rector, automation engineer here at Atlas. Andy, you've been with us
6 years.
6 years.
Yeah.
So,
And put me in the middle of you two.
Mhm.
yeah. Well, you're gonna have to.
She doesn't have to pull the plug. 'Cause
Yeah.
She's hoping somebody will carry the company side.
But Andy, you were with us a couple episodes,
Couple
I
episodes
believe.
ago,
So
episode
welcome
8.
back. Yeah.
Thank you.
Yeah, welcome back. Happy to have you back. We do have 2 special guests in today. Brian Butch,
Yep.
on my left from Modal Shop, and Jeff Monks from EquipCon.
Hello.
Yep. Thanks for coming in, guys.
Absolutely. Happy
Yeah.
to be here.
Yeah. So, you know how this will work? Well, yeah, right. So we've got these fancy schmancy tumblers.
Mhm.
And since we have 2 new guests, you guys each get a tumbler.
Look
at So look at that.
Yeah.
Well,
Thank you
Something,
very
something
much.
to remember us by.
Nice.
See, you even get it at the beginning of the episode,
Yeah.
so you don't have to worry about how this goes.
Yeah, no matter how it goes, you've got a tumbler.
There
So,
we go.
That's great.
yeah.
welcome to
Door
the
prize no matter what.
Yeah. But really, how this will work is we'll just kind of talk through some questions here, and you know, feel free to ad lib and do whatever you want. Let's. So, all right, let's kind of jump right into it, and I'll ask these questions. At times, I'll say who I'm pointing them out to, but I'll just in general ask, what is resonance testing?
Yeah. So resonance testing, I guess before I explain what resonance testing is, I'll just take a second to explain what resonance is.
Sure.
Right. So resonance, if you think of ringing a bell, right? You have a bell, you ring the bell rings at a certain tone. The tone that it rings at is the resonance frequency of that bell. It's the frequency that that takes the least amount of energy in order for that bell to just keep on ringing. Resonance testing is using that same method to do quality testing of parts that are manufactured. So just like the bell, we ring parts as they're manufactured. Based on the sound that those parts make, the resonant frequencies that they ring at, we can determine whether or not parts have any defects in them.
Okay. All right. So then how does resonance testing compare to other NDT methods?
Yeah, so with resonance testing, we use the response of the part itself. We're ringing the bell and recording the response of the part to determine if the part has any defects or anything like that, versus other NDT methods like, eddy current or ultrasonic. You're injecting a signal into the part and then reading that signal back again. So with other NDT methods, the more, I don't want to say traditional NDT methods, but
Right.
the
Older.
Oh yeah, there we go. Older methods is a good way of saying that. You're recording how a signal changes. So you can because you're injecting a signal into the part, you can get a little bit more information. It's not the best way of saying it, but you can get a little bit more information out of a part, like the location of a defect or the type of a defect in a part. With resonance, it is more of a go no go type of test because we're using we're not injecting a signal, we're recording the signal back
Right.
from the part. So it's really good for high volume testing, high volume production go no go testing, where you're not concerned about what the defect type is, where it is in the part, just is there a defect or not a defect within the part.
But when you're saying impact, we have to impact the part. So automation wise, we automate production lines to impact that part to get a resonance signature
Absolutely.
back
Yep.
for a
Ring
go or
the
no
bell.
go
Yep.
signal.
Okay. Okay.
It should be said that the resonant test is a volumetric test. Other NDT methods may be surface inspection only, like penetrance, magnetic particle,
Right.
visual camera systems. They're looking solely at the surface of the part, whereas resonance is volumetric, the entire structure of the part is being inspected with that method.
Yeah, that's a really good point, and I meant to mention that. Thanks for bringing that up, Jeff. Yeah, so with the other methods where you inject a signal, they are only testing the part through the path of that signal, versus just like ringing a bell, the entire structure is being tested.
Okay.
So as a part gets bigger or smaller, you get the different resonance. In our case, we have potentially weight variations. You're also picking up that volume difference as well.
Mhm.
And any other material property change in the foundries, you may be doing ductile iron castings. Is it nodular? Is it not? And that's a great test that resonance can easily detect. Proper hardness for heat treating, proper hardness can be determined quite easily with resonance testing as well. So a number of applications where it's specialized, powdered metal being one that it's just a natural for. Other industries are finding more and more niche uses for it, medical, foundries, forging industry as well.
Correct me if I'm wrong. I believe maybe you and I had spoken previously about this, but say a hairline crack in like a half-pound part is more easily detectable in the resonance method compared to say a 10 or a 15-pound part hairline crack because of that.
Yeah,
whole
so
surface of that.
so defect size, the size of the defect that we can detect with resonance testing is going to scale with the size of the part.
Correct.
Right. So a small defect, hairline crack in a small part is going to be much more detectable than that same hairline defect in a part that weighs
I mean,
several pounds.
not that you're going to have a 10 or a 15-pound powdered metal part. Yeah.
There are
capability.
There are some
we have
out
that
there,
capability. You can stick around for our future episodes that we're going to have because we're going to discuss that topic, Andy.
I think real soon.
Yes.
They need somebody to carry the parts in.
Yeah. We need a big robot.
So and the reason for that, the scaling of defect size versus part size is because we're ringing a bell. You have to have a defect in a part that changes the tone that bell rings at, right? So if you crack a bell, it's going to have a real flat tone to it, right? It's not going to have that clear ringing sound. Same goes with parts. But the crack or whatever type of defect that you're looking for has to be significant enough to make it ring differently to change that tone, right? So it's a very robust method, but there are limitations. Whereas with some of the other NDT methods that you're injecting a signal in, that defect size is independent of part size, right? So, and that's where you get some benefits of one method versus another method as far as what it is that you're looking for in a part.
I know when we're testing production parts, the resonance signature is obviously quite different based on the structure of the part. We can see that when we're setting them up.
And the more you use it, the more data you acquire, the more useful the tool becomes.
Correct.
Really just for process control. Then you'll see trends occurring. You'll know something at the press or something with the powder needs to be done before you're failing parts.
Correct.
All right. So I think we kind of touched on this next question, but could multiple NDT methods be used in testing a part?
Absolutely, yeah. So here at Atlas, there's one of the systems that has resonance on it that's also using eddy current. They're both in line in a system. And the two different methods are employed to test for two different defect types. That particular part's a gear, right? So the eddy current is used to check the hardness in the gear as well, or in the gear teeth, as well as for checking for like really small chips and things in the gear teeth that wouldn't be significant enough for resonance to detect. And then the resonance is being used to detect both internal and external flaws, mainly cracks in the particular part that wouldn't be easily detectable with the eddy current. Probably the most common other NDT method that gets paired up with resonance testing is visual inspection, whether that's human visual or machine visual inspection, to look for surface flaws in a part, chips and things like that, versus structural defects, plating defects, all those sorts of things, voids, pits, missing material, things like that.
Okay. So then, why is resonance such a popular NDT method in the PM industry? Is that simply because of its effectiveness or?
the ease of use, cost,
Okay.
the lack of any consumable materials, reliability, setup.
Yes.
Go ahead and finish on that one. I think that there's a number of advantages. I think in the past, the distant past, magnetic particle was the primary method of inspecting. It's a very valuable method. We'll talk about that in the next episode, I guess. But the mag particle is a great method, fluorescent penetrant as well. But resonant inspection really offers a much cleaner, faster method. Even though mag is very quick, resonance is very quick and very dry and very easy to run and automate.
And that brings up a point that the cleanliness of it matters in some applications. So we're not contaminating it with any fluids that we don't then have to turn around and figure out how we're going to get back off again.
Right.
This is very clean.
Yeah.
As well as the cost of consumables, which are not cheap.
Right.
Yeah, I mean, if I was to boil it down to 2 words, I'd say speed and simplicity, right? So resonance testing is typically the fastest NDT method out there.
Okay.
Machine visual is probably the only other thing that could be kept up as far as running through parts. But with resonance systems, you can test parts as fast as a half a part a second, or a part every half second. Excuse me.
Okay. pretty fast.
That's usually limited by the automation. You got to get a part in the system.
I think he's throwing you under the bus.
Right away, And then
The
we were friends.
limitations with automation.
Right, limitations, but exactly right. No, but
Like an old dog kicking
but
the end of the table.
it's very fast and it's very simple to set up a part and have it be able to run production level testing with resonance.
Okay. Any kinds of parts or materials that can be tested?
Yeah, so it's a really wide range. It's a really versatile technology as far as that goes. Anything that's going to ring and give us a good repeatable signal can typically be tested using resonance, as long as we can differentiate the defective parts from the good parts, right? Most of what we're testing is ferrous materials, iron type materials, steel. There is some stainless steel. We do a decent amount of aluminum, and then a little bit with some of the softer non-ferrous metals. You get into coppers and bronzes and things like that.
Right.
With those kind of materials, we can test with them. You tend to see more part-to-part variation, so it's a little bit harder to capture a good repeatable signal. But I'd say the bulk of the resonance systems that are out in the world are testing iron or steel, one of those variations. Also, Inconel is another really good one if we're talking aerospace industry.
Okay.
Titanium for medical industry works really well.
Right.
Also,
We have had that issue though, where we didn't have enough separation between the two. It just wasn't a good candidate for the resonance. So
It is a comparative test.
yeah, we had
So
to.
you must have good parts and bad parts, known good and known bad. So another method or visual is detecting these bad parts, and that's where you start the resonant inspection. Resonance requires good and bad parts typically to set up a new part for testing. If you don't have that, then you need volume of parts where you'll have to look at data, review it, and find the trends as to where the fallout occurs.
And Mark, from our standpoint, if we know we're going to go into a resonance application with something and we don't have those failed parts, there are occasions that they'll call on the molding setup guy to try to make failed parts
Okay.
so that we have at least.
Yeah, because we're not in the habit of trying to make bad parts.
Exactly.
So
So they may have methods that they go in and purposely cause something. Not that we ever do that on a regular basis, but at least to do an initial setup until we can get a good baseline for these things.
As a baseline, in the absence of known bad parts, that can help you hone in on where you're targeting. But then even in those cases, the actual naturally occurring ones are not forced. So the structural changes may be different. You have to analyze your data for a while until you learn it. And it really becomes just another tool in your toolbox beside a fully automated inspection system on the line. If you use that data further than just go, no go is great. But if you actually utilize that data, you'll start to learn a lot more about your process, and you'll be able to gather data that helps you improve your overall process as well.
I know early on when Andy got down here, that was one of the things he ran into is we were having slight variation from one setup run to the other, and we had
Could be
to.
density, could
Then
be.
you ask those questions, why?
Yeah.
and it just improves your overall process. So you're given a number of tools in your job, and the more you can use those tools and find valuable use for them, the better you can do that job.
That's when you and I started working pretty close together, and we came up with different methods and different. We were weighing them, and we noticed when we saw some density changes, some weight variation, our resonance signature would bend a little bit,
Yep.
and we had to compensate for that. We've been very successful.
And
doing
the
that.
flip side of the detection capability of that situation is you now have data telling you our density's off. Let's fix that where the cause is.
Exactly.
Right.
Yeah.
So NDT as finding bad parts is how most people consider it. It's actually far more than that, and we could talk about that in the next one as well. But that NDT is not a detection of bad parts method. It's a positive acceptance method. That's the technique.
Yeah, we've seen that firsthand.
Absolutely. Yep.
So what about size and weight ranges?
Yeah.
I'm
So
interested.
just like the materials and different types of parts, the size and weight ranges is really broad as well. We have customers that are testing parts that are on the weight range of a gram or two. We have other customers testing parts that are several hundred pounds. Right. As long as we can get enough energy into a part into that bell to make it ring, and metal likes to ring. It's it transmits vibration energy very easily. Right. So it doesn't take a lot of. You don't have to. In our system, we call the part that hits the component that hits the part, we call it the hammer, right? And you hear hammer, people think nail, you think you got to you really hit the part, but that's not really the case. It's just a light tap for most parts. And even if you get on the order of a couple 100 pounds, you're hitting a little bit harder, but you're not slugging away at it. You don't have to wind up and go baseball swing in order to get a part to ring. Some people might want to, but
It's funny. The hammer is the name of the impact device, but we call it an impact tip on the end of the hammer. We should call it an impactor. It's really all you're doing is ringing the part. You're not slamming.
Yeah. What about us here, Andy? What kind of size or weight ranges are we looking at that we use resonance for?
So we have a production run here at Atlas that we pretty much adopted the system to. It was when I arrived, the Modal shop system was sitting here for a different part, and we realized that we could use it for this part immediately. And once we automated that inline in the system, we noticed. Right away we were kicking parts out right and left, and we found it was a gear, and it had a hub on it. We found that crack in that hub. You couldn't see it. You could look all day long. We took it in our lab. We looked under the scope. We couldn't see it.
The only way you could see it is to chop the part up.
But the resonance, kicked it out right every time, and we figured out. We went back to the source, figured out why they were cracking. But we fixed that, and we'd go months. That was fine. Then they'd call, hey, they'd page me on the intercom, come back to our secondary area. I'd go back and it's throwing all these parts out. Something's wrong with it. So you could see the data, you could see the bell curve, and these parts are bad. Take them in the lab, have them cut them, and sure enough, they were cracked. So then we could seclude some of our issues. Hey, let's find out.
The purpose is trap.
Yep. Let's find out
Trap those parts.
where this happened, and it's improved our process tremendously. But those parts are a pound. Typically our parts are smaller, but Joe's hunting for the big parts.
No, that would be Mark. Mark's hunting for the big part. Joe just is trying to help.
Joe's trying to get him through the group for us so we can start producing something.
I'll help you move them.
Okay. So I know we talked about some of the defects, but let's just kind of ask the question: what kind of defects are manufacturers typically using?
Yep. So the far and away the most common defect type is cracks, right? And that's what anybody in any manufacturing method, it's the most, what they're going to see the most and what they're going to try to avoid is cracks, right? So that's most of it. As far as physical defects goes, voids, porosity, missing material, extra material, things like that are very common in the PM world and across many manufacturing methods. If we talk about other manufacturing methods, like in forgings, you'll have cold shut or laps, where two pieces of the forging bars get together and then you essentially have a fold material. In castings, you can also have something called a cold shut, where the material cools too quickly. So those are all sorts of physical defects that customers will use resonance systems to detect for. There's also material property defects, right? So if you have some material contamination in a part or wrong material, we can detect that. In ductile iron casting, a lot of times you're looking for the difference between ductile or gray iron, so the level of carbon nodules in the material. That's a material property that we can detect. So many other things outside of just a physical defect can be found, but cracks are far
By
and
far
most
away,
common, yeah.
number one. Okay.
Speaking of your cracks, though, not all our cracks are manufactured. So, unfortunately, we are in the powdered metal capital of the world. This area here, I've been around it my whole life. We have to get parts from our molding process to our sintering process. We typically have them on big push
trays,
carts,
whatever.
and when they're pushing that cart from our molding area to our sintering area, that handling, that might jar that part. Unbeknownst to the operator, that they created a crack or a crack had happened. And then they go through, some of the handling we have noticed. And we've noticed that. We've picked it out in our resonance, and we've pinpointed that to maybe a handling defect, and we've changed that process. So it has helped us.
Excellent use of the output of the system to be able to do that.
Yeah.
Good for you.
And Andy, here, the testing, when we do this testing, it's usually before it would ever get to a secondary op, right? Like this would be prior to a plating or prior to, any other secondary machining, or not necessarily.
No.
Okay.
So I'm glad you brought that up. So our secondary operations for typical powder metal parts are drilling a hole, tapping, machining, whatever. We have been able to successfully detect untapped holes with our resonance systems. So we would want to do that after our secondary operation. And, hey, this is untapped. And it will verify that and kick it out.
Logically, it's a volumetric thing. If we're taking material away, if we've skipped a step, the system's going to catch that in the ring.
It works.
Any structural change to the component.
Right.
Yeah. So, and just to kind of add to that a little bit, so sometimes a part will be end of line, like right before it goes in the box, depending on what secondary processes it goes through. Maybe there's some benefit. Sometimes it's right after sintering, immediately after the part is made whole, then that'll be tested. And typically in that case, they'd be looking for green cracks, or customers that are brazing components together during the sintering process. We can check for the braze quality there. And that would typically be done right after sintering as well. But yeah, so when the part's inspected, it can happen at any point in time, right? It's just a matter of what you're looking for and what makes the most sense. If you're looking for a green crack and a green crack only, typically you'd want to test the part right after sintering. But if there's other secondary operations that could also cause defects, like heat treat, you can get cracks as a result of heat treat, or drilling and tapping operations, things like that, then you'd want to test more at the end of the line.
Okay.
Typically, NDT is used as an end of production test on most industries. Maybe not powdered metal today, but historically, before the parts shipped, it had to be inspected. Over the years, NDT has moved further and further up the production line, because the sooner you can inspect it and segregate parts that are not going to pass the end of line, you avoid all that value add into an otherwise bad part.
Right. Makes sense. So what are typical end use applications for the parts that are being manufactured and being tested?
So yeah, so most of our most of our customers, 90+% are making parts for the automotive industry. Resonance works very well with the automotive industry because you have a lot of high volume, low cost parts that need 100% inspection, whether it's safety critical or internal engine or transmission components or, drivetrain, something along those lines, that you don't want to build a whole transmission up, find out you have one bad gear in there, right? And we've
Right.
got a lot of time and effort. So automotive is the most popular method or application, end use application. But we also do a lot in the medical industry, firearms components, you could say defense or just, sporting in general.
Sure.
A lot of like commercial vehicle, construction vehicles and equipment, off-road, lawnmowers, ATVs, UTVs, snowmobiles. Medical is another one. There's a lot of really small, intricate medical components that you don't, especially like we have a lot of customers that make parts for like surgical robotic grippers and things like that.
Right.
You don't want one of those parts breaking during surgery or he does bad. So they
not
would use
good.
our systems to test those parts, make sure that there's no defects in there before they get used.
Basically, Mark, it's everything that
It's-
we're into.
Yeah,
Yes,
it
it's our
sounds
entire
like our
industry spread.
pie chart,
Mere-
what
the
industries
only
we're
thing
in.
that I didn't hear him mention was the electric motor and hydraulics, and we actually test some of those with their units.
Yeah, well, and there is to a much smaller extent, right? Because there's not as many applications for it, but there's like electrical motor components, hydraulics, commercial goods in general, and we've done some work where there's been a few parts that are used for. I think there was a blender component that you guys had an issue with some extra material, and it wasn't assembling properly. We were able to worked with Andy. We were able to detect that. There was another part for hand tools, I think, that we were looking at one point in time.
Yeah, so it's really it hits
Pretty
all
much
the
everything.
all the
All
industries.
industries, yeah.
It really doesn't. It's not industry specific. It's a part function.
And it was a typical application where we had visual inspection. We were checking things with our cameras, and it may have been a longer part and we couldn't see all the way down in there, and Brian and I had gotten together and he's like, let's resonance this. We should be able to, and we could do it. We could successfully do it, and it's helped us tremendously to get past that gray area where what method of inspection do we use?
A lot of folks are starting to do that more, even in your industry. A new part comes in and they'll actually have a side system they'll use to set up that part and make sure that the part setup goes smoothly, and basically inspect their problems away while they're doing their setup and troubleshooting. So it's a really valuable tool to use in that regard as well, rather than taking a production system to do that. Is that they actually have a system that just moves around when they're doing a new part. And by doing that, you shorten the part development time.
I can say one thing that has helped us at Atlas is on the visual side of inspection. A part is a part based on that print, and we make it to that print. But we have secondary operations to it, whether it be plating. We send that out of house to get plated. That plating, the consistency of that plating, it's not going to come back the same every time. So that camera may throw that. The plating's good, I'm sure, if it's within spec,
Right.
but that camera was set up to that specific plating. So, I get a lot of operators calling and saying, hey, can you come verify this, come look at this, and we get with our quality department in-house. And the plating's good, but the master image that was on our vision,
They don't jive.
it's different. So it's going to, depending on how tight we have that tolerance set, it's going to throw it out. Whereas the resonance, a part's a part. This is what a good part rings, and anything else, something's
The bad
different.
part, yeah.
Right.
There's more material. There's more
Whatever it is.
There's
yeah.
a crack. There's a chip. There's a missing material. Yeah, it's eased our pain in the automation group setting things up. Set it and forget it.
We like that.
We do.
Yeah. There can be a lot of process variation in PM from one lot to another. Does the process variation have any effect on the test?
Yeah, it can, and that's something that we talked about a little bit, or touched on a little bit earlier. We talked about weight variation, density variation. In my experience, the most common factor that's different from one lot to another lot is a change in density from, between the lots. And that, if you're keeping your geometry the same, then your density is going to correlate to a weight variation, right? So we have an ability to compensate for that lot to lot density variation by weighing parts. And we have an algorithm in our software that allows us to be able to automatically compensate that. So it effectively automates that lot to lot variations. That way you don't have to have an operator go out and make a change to the setup criteria. Because if a part has a different weight, just like a big bell versus a small bell, they're going to ring at different tones, right? You're going to see a shift in that resonance data. So this, by accounting for that weight variation from part to part, correlated that to the density, we can automate that shift.
Okay.
And that doesn't necessarily mean the part's bad. It just means that we've got to make that accommodation so that we don't throw them out
Correct.
because of that, because of what
A lot of
residents-
false
yes.
rejects. Yeah.
Yeah.
If we don't
And so
compensate for that.
we've got to compensate for that.
Yep, and you guys have a system that's doing the weight compensation on it, and it really tightened up the acceptance criteria by removing that variation from one lot to another lot. The ability to sort good part from bad part is much better, and there's a little to no time spent making any sort of adjustment to the criteria. It's just system just runs.
Yeah, we see that lot to lot, job to job. I mean, it's part of the process, and their system, their setup, the way it works flawlessly. We weigh them and adjust that criteria, and it's a software adjustment, and we see it. I mean, we see the resonance signature change. Well, I don't. I got to use my cheaters like you.
It's terrible.
I mean, it's getting
On and
older.
off, on and off. It's like,
But the younger
the
operators,
birthdays
they
have
can
caught
see
up
it.
to me. Too many birthdays.
I bet every one of us wear glasses except maybe him to read. I'm not sure if he does.
I don't need reading glasses yet, but it's
Oh,
coming.
you will.
It's coming close. These papers are getting
those
further
gray
and
hairs
further.
in the
Yeah,
deal are just
right,
so-
yeah, I know.
It's coming soon.
Yeah.
Yeah. Yeah. So for our audience, Jeff, can you tell us the relationship between EquipCon and Modal Shop?
I'd be happy to. I think it's probably more appropriate to let Brian do it because he is the Modal Shop and we are the new part of this team. So I'd
I
rather
see.
Brian make
Okay.
that introduction.
Yeah. So the Modal Shop, we were really the first company to fully commercialize resonance testing. Resonance inspection's been around for centuries. People, you tap on something, you listen to the way it sounds. Oh, that's good, that's bad. But Modal Shop was, one of, if not the first company that really commercialized these systems. We've got upwards of about 1,000 resonance systems on 6 continents around the globe over the last 25 or so years of the system being commercialized. The Modal Shop, we are a test and measurement company. We're focused on modal analysis. We're a sound and vibration company, right? Resonance it falls into that, but the needs of supporting the manufacturing environment and automation and different things along those lines really have always been a little bit of a strain for us because that gets outside of our core competency as a company, right? So we've been working with EquipCon for the last 2.5 years or so. And EquipCon has helped to work with customers, identify applications, things like that. But recently we've changed the business model where EquipCon is very flexible and nimble in their ability to provide automation solutions, customize things like that. So EquipCon is actually taken over the business they're the face of the NDT RAM, the resonance business for the Modal Shop now. Right? So EquipCon is our only direct customer now, and EquipCon has all of the customer base, sales, service, everything else.
Yep.
And that gives we still manufacture the core components. We still have the software that everything is our own core design, and we're still keeping those up to date and making modifications to the technology. But EquipCon is able to better support the customers from an entire application standpoint with custom automation solutions and things like that that better fit the manufacturing environment. So we've started working together in that aspect. We kind of call it an indirect sales model where we're still making the components, but EquipCon is the face of it all.
Gotcha. Okay.
We work very well and close together, but again, the critical components, there's 4 of them really that are absolutely critical to the technology, the software, the microphone, the analyzer, and the hammer. Those 4 items are required to make the test work. Those are all still managed. The R&D, the development, any customization. Modal Shop does that. Once you get that kit and you want to build it into a system, a lot of customers have the capability, like you guys, of doing that. And in those cases where they don't, then we would do the actual integration into a unique production line, perhaps, or a very standard conveyorized line, perhaps. But we do have flexibility, being a small company, to do what the customer needs, rather than like so many companies offer 1, 2, or 3 models of standard, and you make it work. So we become more flexible and able to serve the customers more directly to their needs.
Okay.
So you're going to try to hand it off to him?
No.
Oh,
You know the best thing? You know the best thing about these 2 guys though is Brian's out of Cincinnati and Jeff's out of Indiana.
Mhm.
And whenever we needed anything or I needed anything, I would be getting on the phone. I'm like, I got to run in the office, call Brian. And I turn around and he's standing there. So I don't know if they have different microphones in their systems, but these guys and their response time is fantastic. And yeah, when we need stuff, they're here. I mean, it has worked for us. Great.
Glad to hear.
we appreciate it.
Yeah, our new service, well, he's actually our quality director. He's managing all of the service on the Modal Shop products. Actually, it looks like a younger version of Brian, the backwoods beard and all. So it'll be an easier transition out here for you
Back
folks.
when my beard was
he
one
kinda
color,
likes to say that. But David's a really good guy. You've met him already, I believe, a couple of times,
yes.
and very responsive, former military, out of the aerospace industry. So a real good addition to us, to our staff, to bring him in to really focus on the former Modal Shop business and all of the future business as well.
Pat, we may need to cut something here. I'm just kind of, well, we are going to have to cut it because I'm just going to talk out loud here. But I'm looking down through our questions. 11 and 12, we've pretty much talked about.
Mhm.
Maybe 13, if we want to talk about how quickly that testing can be implemented, or do we not?
Do we really want
I
to?
don't know that we really need that, but we can if it's
Pretty instantaneous, but
Yeah, it's. Yeah, I mean, Andy can testify to, it can be implemented extremely quickly, or depending on what level of automation your app around it might take a little bit more time and effort, but it's pretty simple. Yeah.
It's all based on the quality. If you're given a handful of good parts and a bill sect of good parts.
Why don't we
and a sect of-
Yeah, why don't we
hit
just
that
ask
topic?
that
Why don't we
question?
hit that topic so that he can kind of address that side of it?
Okay.
Because we've kind of alluded to some of those things already. So
Yeah.
go ahead.
Yeah.
So I guess I'll throw this out to the 3 of you. How quickly can resonance testing be implemented into an existing production line? Andy?
I'll take it. Absolutely. So that goes back to our quality department here, where they come, hey, we have a new part. We know these are bad. We verified them in the lab. Maybe they were purposely made bad. So we have some test, something to test against. And here's our lot of good parts. So we'll run them, go do what we call an investigative file. So just like it says, we investigate these parts. We'll run them through whether we have a drop system, and we actually also have an inline system that's automated with a robot. Run them through, and we have a known good and a known bad. So then I'll go through, or one of the operators or one of our quality personnel will go through, and we'll see where them high and low peaks are based on a frequency reading, come back, and we'll set our criteria up to that. And that's our production run. I mean, it depends on how many known goods and how many known bads. I mean, they're not going to come and say, hey, we have one good one and one bad one. You know,
That's not going to work. Huh?
no,
Yeah.
I can't. I can work with that, but I don't, you're not going to like it at all.
Makes it a lot harder when you only have
You have
one.
50 good and 50 bad. Yes. But the ease of setting it up, you know, and then I've called, you know, Brian on the fly. Hey, have you seen something? Yeah, go and, you know, change this a little bit, change that. And you know, now Brian or Jeff's group and David, you know, hey, I got to change something over here. Oh, just, so yeah, the setups is very easy. And we've gotten our setup time down pretty well.
Very, very fast to set up, really. And then the TMS software is the easiest one. I mean, obviously there's competitors and everything. You have a good product, people will, you know, spin off or create or duplicate that technology. So there's been competitors come into the market. But the software that the Modal shop makes is, I think, pretty universally known in the industry as the easiest to use for this reason. And he's very qualified because he's done a lot, but an operator with very little training can learn to do this setup without a lot of difficulty. So we keep it very simple in terms of how to be able to use it.
Yeah. And then strictly from an implementation standpoint, once you get past, you know, we know this part is going to work. We want to get it into production. There's different system configurations where we've got a system that's a core set of components that can be integrated into an existing production line. We have a conveyor-based system where we've literally had customers remove a section of conveyor from a production line, roll this thing into place, and they're ready. You know, as much time as it took to remove that section of conveyor, roll in that other system, they're ready to start testing it right away. So, so it's a very versatile technology, you know, and different system configurations can depend on how quickly you can get set up and actually be running production from a fully automated standpoint or operator assisted type production.
Yeah, and on the control side of that, in our area, we you know, stop the process at that point, run it through their thing, get your go or no go signal, and send that signal back to the system and continue on. So that works. But as I had spoken earlier, you know, not getting back to not every component is a candidate for resonance either. You know, we get parts from our quality department. Here's some known good, here's some known bad. We run them through, and those resonance signals are the same. I'm like, and I've called Brian in a panic before, and David, and hey, I'm not seeing any difference. Am I doing something wrong? Do I have to adjust my microphone, you know, intensity, my frequency there? No, it's not a good candidate for that type of inspection. So then we do our other methods, whether it be vision or so, you know, a lot of times we manually sort of, if it's a small run.
And that's why there's multiple different NDT and inspection methods, right? Because there is no one tool for every
One size fits all.
You have to have multiple different tools in order to do that. So resonance is very versatile. It works for a lot of things, but it's never going to work for everything.
Right. And Joe, we're pretty fortunate here to have Andy and his group
heck yeah.
right in house. I mean, I know that's not, you know,
These guys are
that
here all the
common within.
Yeah, they're here all the time doing
Well, it sounds like
I don't do
he
nothing.
looks over his shoulder and it's like he's got that little devil on his shoulder. So, well, there's Brian, there's Jeff, you know. So
I think
yeah.
I think they just like the area. Don't let them lie to you. I think they like the area.
Yeah.
Hey, did you see them elk over there?
Yeah.
I'll tell you, as far as places that I travel to, this is absolutely my favorite.
Yeah.
It's a wonderful area up here. People aren't too bad either.
Yeah, that's,
Or do you have them fooled?
Put a bag over his head.
they don't know Andy that well. So, no, but we're pretty fortunate to have Andy and his group here. So, you know,
Yeah, we
I
had
think-
spoke episode 8. It was our automation.
Yeah, you and
You know,
Luke.
most powder metal companies don't employ an automation group
Right.
like we do. They bring Jeff's group in. Hey, we want to automate this. Here's a turnkey solution for you, and they're happy with that, and it works for them. Where
But most companies aren't turning over the different part numbers that we are.
exactly,
Months time.
and,
Right.
yeah, I
And
mean
so
they're
really
set.
and all the
knows
different
us completely out.
industries and all the different geometries. I mean,
Yep.
it's just, yeah,
They're setting up a run, and that's running for 8 months.
right.
You know, we're setting up and running for
couple
8
hours.
days.
Yeah. Right.
Mhm.
Or a couple
Or a couple hours, yes.
Yeah, we have several systems that are inspecting the same part, one number, forever.
24/7,
24/7.
365
Yeah.
years and years and years.
Just
yeah.
runs and runs and runs. Yeah,
Can we get
absolutely.
some of that?
Well, talk to him.
I'll start looking. Nobody's ever asked me that before. Let's see what I can do. But well, thanks, guys. I
Yeah.
really appreciate having you. Yeah, it was a great episode. Thanks again
Yes,
for coming back.
Thank you.
Yes.
And,
Thanks for having me.
Joe,
I think that was a wrap
it's
for
been
this
fun.
session.
Yeah, episode 16 in the books, huh?
Jump in, and these guys aren't going to move for the next session.
Well, thank you for watching episode 16 of the PM Blend. And if you would, please follow our socials.